Hello student, how are you? I am Arun sir, qualification Bachelor of Engineering from Jadavpur University. In this class, today I will teach you the resolution of vector, which is very important class. Now, welcome to my channel, Tuition Expert. What is resolution of a vector? The splitting up of any vector into two or more vectors is called resolution of vector. So a vector can be resolved any two vectors or more vectors, any component. These we can resolve any. Suppose this is main vector. Suppose this is main vector. We can split along two components, any two components. These components, these vectors. This is main vector, and these are the components or splitted vector. The splitted vectors is called component of the vector. The splitted vectors are called component of the vectors. Now, if the two components, suppose this is a vector and two resolution, that is, these are components. If the components are 90 degree to each other, then this resolution is called orthogonal resolution or rectangular resolution. This resolution is called rectangular resolution. Now, first we component along any two direction. Suppose this is a main vector. This is a vector A. Now we want to resolve this vector along any two direction. These are called resolution, and these are called the component of the vector. Suppose this angle is alpha and this angle is beta. Now we have to resolve this main vector along two components. Now what will be the component we have to determine. So for this, draw the line parallel to this and draw a line parallel to this. So this is a parallel line to this, and this is parallel to this. Now if this angle alpha, then this is alpha, this angle alpha, and if this is beta, then this is beta. And suppose this is x dash, y dash, and this is rx dash, and this is ry dash. So, and this is the A. Total length of this side is A. Now from the triangle, suppose this is triangle O A B C. Now from the triangle O A B, what get? And this angle is pi minus alpha minus beta. So apply sine rule. We get A by sine pi minus alpha plus beta equal to Rx divided by this. The side A, its opposite angle is this. This angle is pi minus alpha plus beta, and this is side this. The opposite angle of this side is beta. So this by this. From the equal to B by sine B equal to C by sine C. Now sine pi minus theta equal to sine theta into sine beta. So from this result, just cross multiply this into this divided by this. So this is a component. This is one component. Another component, similarly, from the triangle OCA. OCA. From this triangle we get A by, this is alpha, this is beta, so this angle is pi minus alpha. This is pi minus alpha plus beta equal to uh, this RY dash by this opposite angle. This opposite angle is called alpha sine alpha. So from this we get RY dash equal to A sine alpha by, this is the result. So this and these are the result. These and these are the result. Now if the two angle, that is if the components are, if components are orthogonal, then this is called orthogonal component. Suppose this is vector A, two components are perpendicular to each other, that is orthogonal. This is alpha, this is beta. So now this is x axis, this is y axis, so this is called ax and this is y, ay. So what is the result? Here ax, from this we can write x equal to a sine beta. Now put alpha plus beta equal to 90, so sine 90, that is a sine beta. Now as alpha plus beta equal to 90, so beta equal to 90 minus alpha, which is called a sine 90 minus alpha, that is a cos alpha. So very important, x equal to a cos alpha. Again from ry, that is here ay equal to a sine alpha by sine 90 degree, which is equal to a sine alpha. So the component which makes an angle alpha, with main vector, that component becomes a cos alpha. This is very important. And its another component, that is perpendicular component, becomes a sine alpha. So another way we can find the component simply for orthogonal component. Suppose this is a, this is theta, and this is ax, this is ay. So from this triangle, this is right angle triangle. From this triangle, suppose this is base, this is perpendicular, and this is hypotenuse. So what is cos theta? Cos theta equal to base by hypotenuse, So ax equal to a cos theta. Again from triangle also, sin theta equal to ay by a, that is ay equal to a sin theta. So ax equal to a cos theta, ay equal to a sin theta. So this is very important things. The component which makes an angle theta with the main vector, this is main vector, and the component which makes an angle theta with the main vector, that becomes a cos theta, and other part will be a sin theta. From this result we can express a in the terms of ij. Suppose along x axis unit vector is I, along y axis unit vector is j. So we have to express the vector a in terms of I and j. So what will be the result? Now vector, this is the triangle rule. So a vector equal to this vector. So this vector becomes x into I and this ay into j, because this vector is magnitude into direction. Direction is along x axis, so unit vector I here, and here along the direction of y, that is unit vector is j. So this vector is this and this vector is this. Now from law of triangle we know this is the triangle. So by law of triangle, this plus this taken in same order, and this is opposite order. So a equal to, we can write ax equal to very important result. A vector equal to very important result. This is very important to solve any problem. If we take the magnitude of this vector, then what becomes? Obviously it comes a. So if we take mod of this vector, magnitude of this vector becomes a. So what is the result? Root over a square cos square theta plus a square sin square theta, which becomes a. So the vector a, magnitude a, and it makes an angle theta. So in terms of ij, we can express the vector in this form. This is very important. Suppose this is a vector 4 Newton, it makes 60 degree with the horizontal, and another vector is this is 2 Newton, makes an angle 60 degree with the horizontal along this direction, and another vector, suppose this along vertical, another vector this along horizontal. So suppose this vector is a, this vector is b, this vector is c, and this vector is d. Now what is the result of a plus b plus c plus d? To find the resultant of more vectors, and we use generally the resolution of the vectors. So if we express this vector in terms of an I and j, suppose this is unit vector I, and along this is unit vector j. So if we express a in terms of I and j, then we can add. So what is a? A becomes 4 cos 60 degree plus 4 cos 60 degree, it is a cos theta into I. We use the result. We use the result this. So this 4 cos 60 degree I plus this is a, what is b? B equal to, here the component along this and this. Here component along this and this. So this, so b vector can be written as 2 cos 60 degree minus I, because the component along negative x-axis, so minus I, plus 2 sin 60 degree j, which is for which becomes this. So b vector is this. This is a vector, this is b vector, and what is c vector? We can easily write vector c equal to 3 of j, because this vector completely directed along y-axis, and b vector completely directed along x-axis. So this is 5i. So now we can add a plus b plus c plus d. So a plus b becomes a equal to b equal to c equal to d equal to, now we can write I, we can add I 2i minus I, that is I plus 5 by 6i, this 3 root 3 plus 3. We can add I together and j together. So this become the a plus b plus c plus d. Now what is the magnitude of this vector? this is a ax ay, so a becomes axi plus ayj. So what is the angle and magnitude? Magnitude a will be root over x square plus ay square. This is the magnitude. And direction, for direction theta, to get the direction theta, tan theta equal to ay by x. So we use this formula. So magnitude of equal to root over this, and if the vector, at which angle the vector acts with horizontal, to get this we use this result, tan theta equal to ay by x. This is ay and this is ax, this is ay and this is ax. So tan theta equal to ay by ax, which is an inverse of this. This is the angle. Body moves, a body of mass moves along horizontal direction with velocity. After 5 seconds, it turns at an angle 60 degree with horizontal. After 5 seconds, it turns at an angle 60 degree with horizontal. So what is the acceleration of the body? Problem is, a body of 5 kg moves along horizontal direction with velocity 20 meter per second, and after 5 seconds it turns at an angle 60 degree with horizontal. Now what is the acceleration of the body in 5 seconds? So to solve this problem, we use the formula of acceleration, final velocity minus initial velocity by time. We use this formula. So this is initial velocity u and this is final velocity v. So if the velocity remains same here, 20 meter per second, velocity remains same. Here velocity 20 meter per second, here velocity 20 meter, just it turns 60 degree with horizontal. Velocity remain, magnitude of velocity remains same, only it turns with 60 degree. So what will be the acceleration? So here not scalar, we cannot use the scalar a equal to v minus u by t. We cannot use because here direction changes. We use this formula along only when if the body moves along straight line. But this is the vector, so direction changes, so we cannot use this formula. This formula uses only the motion along the straight line. So v, we resolve the v, we express the v in terms of I and j. So this becomes, again we use this formula, so v becomes 20 cos 60 degree I plus this is b minus u. U is completely directed along x axis, so this is 20i by time 5 second 5. So this becomes 10i So this is the acceleration. If the magnitude of acceleration becomes, so this is the answer, magnitude of this. And at which angle the acceleration directed, to find this, so this is 2 root 3j along this direction and minus 2i along this direction, minus 2i. So the result acceleration must be along this direction. Result of this and this. So if the angle is theta, then we can use formula tan theta equal to ay by ax. This is ay, this is ax, magnitude. We use the only magnitude 2 root 3 by 2, which is equal to root 3. That is theta equal to 60 degree. 60 degree with negative x-axis. Now if the direction, in terms of direction, there are 6 directions. This is east, this is west, this is north, south, and another direction up and down. Angle between north and east 90 degree. Use this. So up and down is east, west, north, south lies along a plane, and up and down is normal to this plane. Now, what is the direction of this? Suppose this is north. Suppose this is north. This is west. So what is the direction here? Direction is 60 degree. We write direction of acceleration is 60 degree north direction of west. The vector A makes an angle with west, so we write here of west. The vector A, that is acceleration A, makes angle with west direction, so we write here of west, and it is directed towards north, so we write here north of west, 60 degree north of west. We can also write from this, if this is 60 degree, then this becomes 30 degree, so we can write also this 30 degree west of north, because this makes an angle 30 degree with north, so we write here of north directed along west direction, so here we write west, and the angle at which it makes, we write at position this of this. Suppose what is the vector AB? What is the vector AB? What is the vector AB, or what is the length of AB? Length of AB, if this becomes 60 degree, then from the triangle it will be equilateral triangle, because this is 60 degrees, so these two sides are equal because it is radius, so this angle and this angle will be same, 60 degree, so this is equilateral triangle, so this side will be 3 meter. But if this angle is not 60 degree, suppose 30 degree, then what is the result? AB. So find the vector AB. We can find in terms of I and j. Suppose this is I vector, this is I vector, this is j vector. So we denote I and j along x-axis and y-axis. Now OA vector equal to 3 into I vector, and OB vector equal to, this is magnitude is 3 cos 30 degree I plus 3 sin 30 degree j. Okay, so this result is this OB. Now from the triangle OAB, we can write OA plus AB equal to OB. So AB equal to OB minus OA, which is equal to OB. OB vector is this. Minus OA vector is this. So this becomes so AB vector is this. So we can find the magnitude equal to root over this way. And in vector form, AB vector is this, and the magnitude will be this way. So this is the end of the class. More difficult problem in of IIT or NEET will be discussed later. Thank you.